Hi and welcome back to the Lightboard series. Today we've got a great topic. We're going to be talking about key considerations for architecting VMware by Broadcom Hyperscaler solutions. These solutions we're referring to are things like Azure VMware solution, Oracle Cloud VMware solution, Google Cloud VMware Engine, and also VMC on AWS. So today we're going to go over the all-important node choice. The choice of node can make a significant impact to the performance as well as the cost and the resiliency of a solution. So very important choice. Let's get started. Let's start by looking at our customers' requirements, because obviously the requirements are critical to making sure we choose the right node size and the right cluster size and things like that. So this customer, quite a small customer, has only got 440 virtual machines. They've got 1,750 vCPUs, 6.3 terabytes of RAM, and 76 terabytes of storage. Let's now check out the different node options we have for this example. Okay, let's now talk about the different node choices that we've got for this example. So we've looked at our customer requirements and we've got these two node choices. One is a scale up, which is quite a large node, which has got 128 cores, 2 terabytes of memory and 50 terabytes of physical storage capacity, versus node B, which is significantly smaller at 36 physical cores, 768 gig of memory and 19 terabytes of physical storage. Let's see how these translate into cluster sizes. Okay, so now we've looked through our customer requirements, we've checked out our different node choices. Now let's talk about the cluster sizes that have resulted from the requirements and the node choice. So from a scale up perspective, if we're using node A, we need 5 nodes in the cluster, and this cluster would support n+1. It's not sized for n+2, but if we did need n+2, we'd be losing roughly 40% of those resources for resiliency. The scale out design used either one 14 node cluster, or you could split that into two clusters of 7. If you did that, your overhead would be, for n+1, it would be 14% for the 14 node cluster. If you did 2 clusters, it'd be 14% per cluster, which effectively equates to 28%. So much lower overheads than the scale up architecture. So let's get into the advantages and disadvantages of these topologies. Okay, let's talk about the advantages of a scale-out architecture. So obviously what we can see here is we've got either 2 clusters of 7 or 1 cluster of 14. Basically what this translates to is a lower resiliency overhead. And what we mean by that is the cost of resources to provide your n+1 or your n+2. So in this case, we're looking at 14% for that 7 node cluster for n+1, or if we went n+2, it's only 28%. Which obviously is significantly lower than the scale-up architecture. It also means that when something occurs, we have a smaller failure domain, meaning that we've lost 1 out of 7 nodes or 1 out of 14 nodes in the larger cluster example. So less impact, less VMs to fail over, less data to rebuild, lower overall impact on the cluster. So this means the cluster can rebuild faster, with more nodes contributing to that activity, meaning it's more distributed. So there's lower impact both at the front end on the virtual machines and lower impact on the back end drives as well. So this is a win-win. So we also have more usable capacity. So obviously in our scale up example, if we're reserving 20% for n+1, we're only using 80%, which can then be chopped up into, for example, 2 if we're using FTT1, or chopped up into 3 if we're using FTT2 for an n+2 configuration. So that's pretty inefficient. So obviously at the scale out topology, what we can do is we can use something like RAID 6, where we've got 4 pieces of data and then 2 parity bits, and that can be spread out across the cluster. This results in more usable capacity for the same physical underlying storage. So this is a big advantage, especially with vSAN express storage architecture, where the RAID, both performance and resiliency, is much increased. And the next point, of course, is performance. So where we have more nodes in a cluster, we have more virtual storage controllers sitting in the kernel with vSAN to drive that I/O. So this means we can put workloads on different nodes. We've got more controllers driving the I/O at the front end from a read perspective, but we've also got more controllers servicing the writes across the cluster. So this is a huge advantage in HCI to use a scale-out architecture. From a virtual machine perspective, which is often overlooked, we've got DRS, which has been around a very long time. It works very well. It's got more options on where to balance the workloads, which means we might have some noisy neighbors, we might have some big, small, medium VMs. It's going to make sure that the complementary workloads are grouped together. That's far easier when we've got more choice in our cluster. So a 7-node cluster gives us a lot more choice. Then if we talk about scalability. So let's say we've started with this 7-node cluster, or even 2 7-node clusters, and we need to add more resources. We can just add one smaller node, which is a smaller incremental cost, and it gives us the benefit we need. If we need a lot more resources, no problems, we can add 2 smaller nodes or 3 smaller nodes, but it means we can scale at smaller increments. From a scale-up perspective, even if we only need a small amount of resources, for example, 36 cores, we would have to add 128. Or we would have to have a mixed node type cluster, which can lead to complexities as well. So much easier to scale, lower cost, and then when we scale with the same type of node, we don't have to factor in the complexities of n+1 or n+2 potentially changing. Okay, let's talk about some of the disadvantages of a scale-up architecture. So in this example, we've got 5 nodes in our cluster, and realistically, in the event one of them fails, it's quite a large failure domain. So what we mean by large failure domain is the resources in one of these nodes is 128 physical cores, 2 terabytes of memory, and 50 terabytes of physical storage capacity. So in the event of that failure, what happens is all those VMs need to be recovered and distributed across just 4 hosts. So 128 physical cores, we're talking about 32 cores per node which have to be used. Then we're talking about 50 terabytes of storage has to be rebuilt across the environment, which is about 12.5 terabytes per node, which is quite a large amount of data to be rewriting. We've also got about 512 mega RAM potentially, which has to be split onto each host. So, that's a pretty high impact for the cluster. We've got new resources standing up, and we've got the back-end I/O performing the rebuild after the storage failure. So quite a large impact. Effectively, we've lost 20% of our cluster's resources. So single failure to lose 20% seems like a pretty large risk when we have the option of scaling out. So this really comes back to that high resiliency overhead. So because we've got such a large amount of resources in one node, this is our overhead for n+1, 20%. Of course, n+2, we're at 40%, which is pretty inefficient. So the next one really is we're storage constrained. So in hyperconverged infrastructure, the idea is that lots of nodes contribute to the storage capacity. So if we have enough CPU and RAM, which in this case we have a lot in the nodes, but we don't have enough storage capacity, then we are either scaling out with more nodes that are equal in size, becoming less and less efficient, or we're using external storage, or we're doing other things that might complicate the environment. We can solve this with a good scale-out architecture. So the other issue with the rebuilds we talked about is it's a slower rebuild because we've only got 4 nodes participating in that rebuild activity. So a quarter of the I/O has to go through each of those hosts. This translates to a longer rebuild, which means you're at risk of a subsequent failure for longer. So it's not just that there's a high impact, it's not just that the rebuild is slow, it's that your risk of an outage or downtime or data loss is increased due to the choice of a scale-up architecture. But there are some advantages, of course. It's not all doom and gloom. So if we need to support very large virtual machines that are, for example, larger than 36 vCPUs, then certainly a larger host would help with that. If we've got large memory requirements, large database servers, a large amount of memory helps us not only support the workload, but house it within the NUMA node, which means we get the best memory performance possible. My argument in this case is if we've got such large database servers or business critical apps, we probably should be looking to scale them out, or we should be looking to right size them appropriately. There's also a lot of other things we should do at the virtual machine layer to optimize before we scale up virtual machines, but that's a topic for another video. So thank you very much.